certification program. Just Google Spark certification, you'll find this. No, this is not. Oh, certified Spark developer. And then it's an online test. You do it, and then your certification will mail to you. There's also a very active LinkedIn group about Spark, and people organize study groups to do the test online. I don't know if there's any.
Also, there is meetups.
Yes, there are Spark meetups. You could do special meetups for doing the test. Okay, so by the way, please feel free to ask questions if you have any questions while I'm presenting them. I'm here to answer questions, basically. Don't shy away from asking questions. Okay, so how to get started with SparkR?
That's a good question.
Yes. Okay. There are a number of ways you can use SparkR. If you have so let me start with the first one. That's the first thing I would do if I wanted to play around with something. I just try it on my laptop. To try it on your laptop, do these steps. Download the latest version of Spark. Right now is 1.5.2. And there are different ways of downloading it. The way I recommend you do it for SparkR, check out the GitHub. Check out this branch from GitHub. Check out this branch. Okay? And then you end up with a Spark directory. Go into that directory and then you build your Spark using either Maven or SBT. I use SBT. That would be SBT/SBT assembly. What it does, it compiles all of Spark's code and then creates an assembly jar file, or what's called a fat jar file. That's like a jar file that contains all of Spark's binaries. Then you go into the R directory. Inside there, as I said, there's an R directory. You go in and then run this command, install-dev.sh. Okay? When you run this command, it's going to try to install SparkR package on your laptop. So at this stage, you might see errors. For example, if you don't have R installed on your laptop, you get a failure, you've got to install R. So you go install R and then run it again. When you try running it again, you might get another failure because you're missing some packages. So basically, look at the error you get, see what is missing, and then install those packages or those binaries that are needed until you can run this command and get success. Okay? Once that's done, you have installed SparkR, and you can start using it. You just type bin SparkR, that will open an R shell for you and launch a Spark application on your laptop and connect them together, and you can start trying out SparkR. So this is the steps you would do if you want to try SparkR on your laptop. On your cluster, any version of Spark beyond 1.4 has SparkR. Basically, SparkR was added in Spark 1.4. So if you have Spark 1.3 or 1.2 on your cluster, unfortunately, there is no SparkR in that version. You have to upgrade your version of Spark. From what I understand, like CDH and like maybe HTTP distributions, Portmore distributions might not have the latest version of Spark. So you need to work with your DevOps team or your cluster administrators to figure out how to get the version of Spark that has SparkR installed, and then you can use it. Another way of trying out SparkR is using one of the Spark services that are offered. Microsoft offers Spark as a service in their cloud. Amazon offers Spark as a service in their cloud. I think Google is either working or they just announced something. And you can also use Spark in Database Cloud. And also there's a 2-week free trial that you could log in and just use for free. You just pay the cost for the Amazon machines that the clusters you launch, no additional cost. So you can try SparkR there inside our notebooks, and hopefully I'll show you how that looks. Okay? Obviously, also if you encounter any problems with installing it on your laptop or deploying it on your cluster, there's a Spark users mailing list. Feel free to post questions on it. Someone from the community will answer your question and you can follow up. Okay, so the last slide in this part of my talk is the roadmap. And obviously, no one, this is basically an open source community, and the community decides what the roadmap is, and the way it works is that, if the community works on something, that will happen. If it doesn't work, that won't happen. But based on my conversations with the active members of SparkR community, and I'm looking at the JIRAs, these are the three things that are kind of planned for the next 1 or 2 releases. First, exposing existing MLlib functionality beyond GLM in SparkR, so we can use machine learning out of box in your R environment. That's work going on. Then there's a proposal for supporting UDFs in R. The way it works is that you distribute a function and a local R data frame to all the workers, and then have them run that function on that data frame with different parameterization and get the result back as either a local R data frame or a distributed data frame. Basically, once this is implemented, we will have temporary or ephemeral R processes running inside the workers. And then something that is always going on is improving and completing the data frame API in SparkR so they look and feel very much similar to our API. So that's always going on. So far, any questions about how to deploy SparkR or the API? Is that the roadmap? Okay. So let's go to the last part, and hopefully this is going to be fun. Some hands-on experience with SparkR. First of all, let me go through the workflow of data scientists and is question? Let me go through the workflow of existing R users in tech companies that have big data, how they use SparkR. They basically, if they want to use how to use R, I apologize, they basically have to use R in conjunction with other systems. When I talk to data science, some of them say, oh, we just buy a very large machine and try to fit our data on it. That works until it doesn't work. Until your data is so large it doesn't fit on a single machine. So basically, from that point on, they start using it in conjunction with another framework. Some people use it with Hive, some people use it with Pick, some people use it with existing relational databases. For example, the data is in an Oracle database or in a SQL server, and they just query it from within R using ODBC connectors in R. So the workload looks something like this. There's distributed data, and then they use some framework to query the data into that framework, read distributed data, then load it, clean it, transform it, and then once it's kind of ready, they do some aggregation or some sampling on their big data to make it smaller. And then when it's smaller, they write that smaller data set in local storage. Once it's on local storage, they can use their beefy workstation to read data into R and then analyze it. And basically do exploration with it or do model fitting on it. And if at this stage they realize something didn't work, they have to go all the way back, load the data again, do the ETLing part again, and then snap. So for example, at the last stage, you notice, oops, I didn't do the right aggregation. I should have grouped by both date and user. I only grouped by user. You go all the way back and do the grouping again. Or if you notice that, ooh, the sample I generated is too big or too small, you have to do it again. Write it again and read it again. Obviously, this is not convenient. One obvious problem and bottleneck is this local storage here. Everything has to be written unnecessarily once. Another obvious problem is that you need to manage and learn 2 different frameworks and languages. Your logic, analytics logic, or data science logic is across 2 frameworks. Part of it is in R, part of it is in, let's say, Java or Pig or whatever. Your model or statistical analysis can only be on a subset or like a sample of the data. And finally, this is kind of inconvenient. When we talk to people, they're not happy with this workload. They want to be able to iterate fast. This iteration cycle is too long. For some companies that have a lot of data, like my last job when I used R with big data, I had to like launch a job, let it run overnight, come the next day, and then load the summaries. I generated a lot of summaries, load the summaries and then analyze them. And then sometimes you do that and you notice, oops, I didn't get the right column, or I didn't get the right sample. So I have to launch another job in the morning and then wait until the evening when the jobs are finished and then try it again. So SparkR kind of changes this. The workload doesn't look like this anymore. First difference is that there is no need for local storage. You don't have to save data on a local disk to be able to read them. Second, there is no need for a secondary framework. All your logic and code can be written in R. So you have a single R file that you can check into GitHub or your version control system. And finally, because Spark has this distributed caching mechanism, you can cache your distributed data in memory and interactively query it and analyze it. So you cache your data once, that might take a few minutes or even longer. After that, you query it, and if that's not the right thing, you just query it again and again and again, and each query takes a few seconds. So this is the new workflow of data science with SparkR. An additional thing to note is with Spark, you can move between languages. Although I said you can keep all your logic in R, some people prefer different languages for different tasks. I'll give you an example why. But basically, because using the temp table concept, the fact that a table and a data frame are two sides of the same coin, you can move between languages. You can move your data between languages very conveniently. So here, in this example, I am reading data in my R code as a data frame. I do some filtering or some other analysis on it. And then I register it as a temp table. And then I open my Scala application and continue my work on that temp table, basically. I do machine learning on it. And then I can just, after this register the result as another temp table, go back into R and do something in R again. So I can move between languages. I can have access to the same data seamlessly across languages. One case where this ability to have multiple languages on the same data and the same analysis we find is with data engineering teams. So in many companies, there is a data engineering team and there is a data science team. The data engineering team's job is mostly managing the data pipeline, basically making sure that the logs get collected from all the servers running in the data center into distributed storage. The data engineering team usually has a pipeline for this thing continuously running. And what we have seen, they prefer having their jobs implemented in like Java or Scala or sometimes Python. So they want to have a jar that doesn't change. But the data science team, or the data scientists, want to use R for exploratory analysis or visualization of the data and generating reports. So they can work together with Spark. The data engineering team can have their data, their pipeline in, let's say, Python or Scala, and then they save the files on distributed storage. And the way they do it, they just append on some existing directories. And the information about the schema of the data is saved in, let's say, Hive metastore. That's very common. The data scientists, when they want to analyze the data in the morning, they call refresh table. Refresh table, what it does, it basically refreshes the Hive metastore so it knows about the latest files that have been added since the last time refresh table was called. Basically, it refreshes your table. After that, they use the table call that I introduced and get the contents of the table as a data frame, a Spark data frame, And from that point on, they just do their interactive analysis and exploration and visualization. And then they can publish or share their results with their bosses or the rest of the company. So that's the workload we see common in SparkR users, basically. Any questions about the slides so far?
How can we configure a high metastore server? Do we in Spark job or in configuration files?
Configuration files. So there's SQL context. There is an equivalent. There's a subclass. A subclass of SQL context called Hive context. When you create a Hive context object, you can point it to a Hive metastore, and then from that point on, when you call save table or refresh table or whatnot, it will talk to that metastore. So check out the Hive context API.
Thank you.
Okay. So let's do a demo. Maybe make sure I get the right setup here. And please, again, feel free to tell me if something is not clear or you have questions. So this is the database, the database workspace, what we call workspace. Let me do a very quick overview of what it is. You have a workspace, you have tables, clusters, jobs, and accounts. So let's start with clusters. This is where I can manage my cluster. As you can see, I'm running a cluster named test that has 21 nodes. So I can configure it and say, I only want 15 nodes. Confirm. So it's basically terminating some of my nodes and kind of shrinking my cluster to be smaller. It's doing it. I can also launch other clusters and say, small cluster, and this time I only want 3 workers. And I can launch it. It'll basically it's starting nodes in Amazon. This is running in Amazon's cloud. Starting nodes in Amazon and installing Spark binaries and configuring it, and then running Spark. So I get a Spark cluster right away. So this is setting up Spark, and we'll be ready in a few seconds. So that's how easy you can manage clusters. Okay, and it's attaching the libraries, and it'll be ready to use. So now let's do some examples. Create a folder here and call it folder. And I create a notebook in it. Or it's called R notebook, and I choose the language to be R, and I attach it to the test cluster. So there you go. Now I'm in the notebook. So now I can type commands and use them. How many people have used the IPython notebook here? Great. So you are familiar with the concept of notebook. This is very similar, only for different languages. This is basically my R environment. I get results back. So the first thing I'm going to do, I'm going to use the I/O API and read data. So do this. By the way, is it clear in the back? Should I zoom in? Is it better? Or should I zoom in a little bit more? More? There you go. It's good? You good? Cool.
I guess you lost right side.
Yeah. Well, I'll scroll I'll scroll to be able to read. Let's do one. So this is readDF. I'm having the SQL context. By the way, when you start an R notebook, you already. when you pass an R node, you create an R notebook, you already have a SQL context. So I can type SQL context. It's already created and set up for me. Hopefully the network is going to be good here. Play nice with us. Okay. Oh, that was weird. So, oh, I see. Okay. Wow. We are just connecting. You see, in return, it says a Java reference of type Hive context, ID2. So basically what it is just a wrapper, and an R wrapper around a Java object. And Java object that is wrapping is a Hive context, which is basically some type of SQL context. Okay. Now I can use it to read data. So I'm going to use it to read data from S3. I've already mounted my S3 bucket in this directory. I'm going to use the CSV data source. The data is delimited with tab and it has a header line. So let's run this command. It should be fairly quick. So that shows we are kind of having a flaky connection. So basically these will take longer. So our job finished and it read our data. So I can see the Spark UI by clicking here. Again, if the network is fast enough. By clicking on this, I can see the Spark UI. People who use Spark are pretty much familiar with the Spark UI. It's a great tool to see how your job is running and diagnose and see how many tasks are there, how long each task takes, how much failure we get. I have to wait a few seconds for this to load it in. To show the Spark UI, I can do something else and do it in the background. And open clusters. Go to the clusters page when it loads. And then I'll show the Spark UI there. So let's continue with our demo. If I do head wiki, so I just read a data frame. I read this data, which is about a few hundred gigs. I read it in the data frame, and I want the first few lines of it shown. So let's wait for this to return. Is everyone on the Wi-Fi?
We have another GSM connector. I will look for it if you want.
That's right. So this just returned. As you can see, I have a bunch of columns. There's an ID, there's a title, the date that the last article was modified, and then there's a text of the article, which is most of our data. The modified is just strings. So I'm going to create a new column just to show how the data frame API works. Call it date, and it's going to be converting the text column to date object. Okay. So basically, this adds a new column to my data frame. Oh, they're not going to do fine now. And converts it. So now I have an additional column. Then I'm going to be caching my data. So I say cache it. And this doesn't do anything. It just tells Spark, hey, just next time you have to do anything on this data frame, keep it in memory. Don't let it go out of memory. And now, if I call dim on my data, which is dimensions, it will have to count all the rows. And while it's counting all the rows, it's going to keep everything in RAM, and the next time it'll be much faster. So now the job will start. Believe me, this is much faster. Oh, there we go. When the network isn't. And while it's running, you can see how many stages it has. This stage and this stage. It shows the total number of succeeded versus planned tasks. Very helpful to debug your. Let's go to the cluster stage. If I click on this page, it gives me the Spark UI. Also, what I'm going to do, I'm going to terminate this small cluster and reconfigure my test cluster to be running it again and make sure. So this is finished. It tells me that it has 4 million rows and 6 columns. Okay? So now I have my data in cache and I can do explore it much faster. So look, this took 57 seconds. So let's do it again. This one I call n row, which is like just number of rows of wiki, and see how long this one takes. Because it's in memory, it should be faster this time. So the actual job took 0.3 seconds, but it took much longer to fetch the results from our server. So, yeah, you need a good network to take advantage of the power of Spark. Okay, let me do like a few more things, and I will open up for questions while they're running. By the way, while this is running, we could also do Q&A, so you can ask me questions. So I'm going to install this package called MacReader. It's very convenient. I recommend it when you're using it with the SparkR API, because it allows you to pipe functions into each other so you don't have to nest functions. It makes your syntax cleaner. If you're a developer, R developer, I highly recommend this package. So you see, it installed the package in my notebook and then imported it. Now, I'm going to use this pipe operator that this package just brought into my notebook. So I'm basically taking the data frame, I'm calling group by date, and then I count the number of rows. You already saw an example of this in my slides, right? So let's run it. This will basically give me a new data frame that has a date and the number for that date. I call it data. So that's I misspelled the column name. Run it again. And it's done. Now I have another data frame, and if I call n row on that data frame, it'll tell me basically how many rows are in that data frame. And I don't expect many rows because the number of rows is equal to the number of unique days, right? It's only 3,000 rows, about 3,000 rows, okay? Now that it's only 3,000 rows, I can collect it. So let's see. Right? So why did I do this counts before I'm doing the collect? Because I should be very careful not to collect a very large data set. If I do that, I may destroy my driver R process, because a lot of data is going to be sent to the driver process, and it may just get overwhelmed and stop responding. But now it's small, I feel safe doing it. Now I have, so there's the difference between this and this is that this is a local R data frame, whereas this is a distributed data frame. Okay? Now I can basically start visualizing this. Right? This is from this point on, it's basically an R data frame like any R data frame. And I can do what I normally do with R data frames, right? Configure our plot. This line basically says I want the width of my, the height of my table to be, again, weight, to be 500 pixels. And this will just generate a plot and we'll see it. Now the plot is done, it's fetching it. Okay, that's fetched as well. So this is the plot. This shows the number of modifications to Wikipedia per day. There seems to be these spikes. Okay, so I had a longer demo, and I had also a machine learning demo. We could do two things. I can continue and do like a machine learning example, or we could do questions and answers. You gotta choose.
Demo.
The machine learning example? Okay. All right. So let's continue with the demo. So I was curious about this spike, what it is, and why we're getting that spike. So I'm going to zoom into this spike. And to zoom in, I just basically limit the date range. Again, date. And you see that, it is actually in that date range. So I want to find the date that has the maximum number of modifications. So that needs to be 21st of March in 2013. So let's see what happened during that day. Simple SparkR code. What it is doing, it is taking, again, it was going to fail because of date. Just type it. So basically I'm filtering to only get data for that day, and then I group by user, and then I count. And then I collect it. So now if I ordered all the users that had modifications on that day, and I basically list the users that had the most modifications on that day, I see that there are these bots that had more than 1,000 modifications on that day. That explains why there was a huge spike on that day in terms of number of edits to Wikipedia. So that was very interesting. So basically, it kind of intrigued me to look for other bots, right? So I'm going to find all the bots, and I'm going to be using a very simple heuristic to identify the bots. And you run it and explain what it does. So what this is doing, it is grouping by date and user, and then finding all those users that made more than 1,000 or actually 2,000 modifications on a single day. So if someone does more than 2,000 modifications on a day, it can't be a human. So I call it a bot. Now, let's see how many we found. 16. Take a look at it. Yeah, the names do have like yo bots and other bots names in them. So the heuristic seems to be working. Okay. Now I can basically visualize the data, basically all the edits of these bots. I can subtract the edits done by the bots from every other user's edits. This is the bot activity. I'm going to do some more example here. You change date, and I explain what I'm doing. Data. So Basically, I can create an R data frame that has two columns, human activity and bot activity. What I expect is I would expect human activity to be kind of smooth, which seems to be the case. It is fairly smooth. There's some spikes, but those aren't huge. And I expect, if I change this to bot, I expect bot activity to be very fluctuating. And you can see it's just fluctuating all around. So our heuristic is working fairly good. We do get a smooth curve when we only look at human activity. Okay, now the next thing I wanted to look at was what are these bots doing? Right? I had no idea what they were doing. So the first thing came to my mind was that let's look at the articles that these bots are touching. But there are so many articles, I can't look at all of them. So I'm going to do simple topic modeling on those articles. So what this does, it basically filters the edit history for all the users that were identified as being bots, and then creates a new temp table called bot activity. Right? So basically this temp table, it contains all of the edits by those special users. Now, I can take this temp table to another notebook or another language and use it. I'm going to use Scala this time. A notebook, call it topic modeling, and choose Scala as the language. Connect it to my existing cluster. This is important because the data is only on that cluster, not a different cluster. And now I'm going to fetch an existing notebook that I've already written and saved in GitHub. So it's fetching that notebook from GitHub. I'll get it here. I'll switch to that. Actually, this one. And I restore to this revision. So basically, got a special, specific commit on that notebook. That you really want to do that? Yes. Okay, now this notebook. Let me first start running it because it may take a few minutes, and then explain what it does. So first I'm going to create a data frame, this time in Scala. By running this SQL query, it does basically get the ID, the user, and the lower text content. And run that query, and I'll get a data frame back as a result. So, I'm mixing SQL inside my Scala code. Now I can just run all of this notebook. That will run my notebook, and while it's running, I'll tell you what it does. I'm importing some ML packages, and then I'm tokenizing the text, the kind of fairly standard practice when doing NLP. And then I have some stop words that I have already stored them on my bucket, and I add some more stop words by looking at the text. I found that there's text, stop, other things in it that are repeated, so I just add those stop words. So I basically filter all those tokens for those stop words. I don't want them in my data. And then I count them, so I want the frequency of words. So that's the count. And then now I want to use LDA, which is latent Dirichlet allocation. It's fairly common topic modeling algorithm. And I set the maximum number of iterations and the number of topics that I'm looking for. And now I'm basically running that job. So basically I constructed a pipeline. If someone is familiar with scikit-learn pipelines, this is very similar. You construct a pipeline, and then you give your data to your pipeline and have it run. Have your data go through the pipeline. So my data is going through the pipeline, and the model is being constructed. It'll take maybe a few seconds or maybe a minute. So at the beginning of this, it'll cache data in memory, so all the subsequent iterations won't be touching the disk. By looking at the Spark UI, how does the network do better? Oh, there you go. So it's the Spark UI. You can see the events timeline. My colleague Andrew Orr had a talk at the Spark Summit in Amsterdam that explained how to read this UI. I encourage you to watch that video if you're interested in more details. The DAG visualization. While it's running, it might take like a minute, a few minutes more. Does anyone have any questions? Yes?
Can you compare other languages that can run on Spark, for instance, Scala and Python in terms of experience for range of usage areas?
So in terms of performance, you said?
Yes.
So if you use the data frame API, as long as you're using data frames, you get the same performance across languages. So you get the same performance between R and like whether you use R or Python or Scala. There is a catch, and that's if you use. There is a catch, and that's if you use user-defined functions in Python. User-defined functions in Python, unfortunately, have a performance penalty. But other than that, the performance of data frames is exactly the same between R, Python, Scala, Java. If you're interested in why and like more details, Michael Armbrust and my other colleague Yin published a blog about the internals of data frames when data frames were introduced. Actually, multiple blog posts. If you Google for data frames, Spark Data Frames blog, you'll find those posts. You can read them to have more details. Okay, so let's see how this went. So that's done. And then I'm printing the keywords for top topics. So this is book, South, River, War, North, one topic. The other topic is company, news, university, film. And there's some overlap between the topics. You can see album, music, song, band, guitar, so on. So, we have been able to identify some topics, right? So now, one thing I'm going to do, I'm just going to run a bunch of code. Let's know what they do. Not very important. I am taking my model and then applying it on all the data and getting the top, and getting the top 3 topics for each document, right? So basically, I'm using the model that I just built to predict the original data. And then I'm taking that and saving it as a file in my local, in my distributed file system. But I'm repartitioning it to 1 so that I get only 1 file. This is another way of communicating data between Scala and Python and R. It's not recommended. Actually, I would have been better off just registered as a temp table and read it as a temp table in my SparkR. I just did it to show you that the old workload of saving data onto local storage and reading it again still works. You can use it here. Now if I go back to my R notebook, I can read this data. Again. So So I'm basically reading that single file and transforming it. And now I can generate an interesting plot. I'm going to generate a plot and show the topics, then the frequency of articles in each topic for each robot, and see if robots have different behavior in terms of the articles they're editing. Or like there are specific articles that are more likely to be touched by these robots. So this is the plot. See how it looks. Just type something in here.
You got everything.
Oh, sorry. Right. So this failed. Could be a file system error. So I can do listing on the file system. I think the name is also use the other media. Might be the problem with the file system. Or another thing I can do, since this wasn't a good idea to begin with, I can just register this as a temp table. So here I have topic by user. I can do this. Register temp table. Topics for user. You can run this instead of having to save it under it. Take another question while this is waiting for network. Another question? Anyone else wants to translate? That thing disappeared, so hopefully this will not return. Again. Yes.
Why do you use color as the machine learning language.
Right, so this topic modeling algorithm has not been exposed in SparkR yet. So unfortunately, the Spark API in SparkR isn't in par with the Scala API. Connection. Oh, wow. It's not even safe. It's not even it's not even able to submit my command. So I'm going to refresh it. And oh, I see. Okay, I know what the problem is. Do it again. That's the very change that works. If it runs over. Any more questions while this is running?
So, can you share these notebooks with us?
Yes, absolutely. I'll email you these notebooks so you could open, like it's going to be an HTML file. You can open them and see the code and the result.
And you can also share us your slides. Is it correct?
Yes, I'm going to send it to both of you. There was another question here? Yes.
What is the lifetime for Spark objects? For example, if I disconnect R from the server, do they die immediately?
So it depends. By disconnecting R from your server, you mean your driver is still running, but you just stop the R process, right? Is that what you mean?
Yes, or if I'm running the driver on my laptop and disconnect my laptop from internet, for example.
Right. So the objects, so here's the thing. First of all, the driver should be ideally running in the cluster, because the driver and the workers communicate a lot. If your driver is on your laptop and the workers are in a remote data center, the performance is not going to be good. Okay? So if you disconnect your driver, imagine you run your driver on your laptop and then close your laptop. The workers lose their connection to the driver. That Spark cluster, I think, will be dead. So the driver should always be up and running.
When the driver is on the cluster, and is there a way that I can connect to the same context and get off the context and come back again? For example, in R you can save the sessions. Can I do the same thing on the Spark side as well? Through SparkR?
No. The best way to do it is to save your tables in Hive, and then use Hive as use Hive to persist your meta store information, your table information, and your actual data is on distributed file system. So next time you create a new Spark context, you just read the table information from Hive Metastore. let's try this. I'll get to other questions right away, but let's try this. I want to make sure you get to see the final result. So I'm going to read the topics is going to be context. This was the name of our timetable, and I will collect it. And then I run this. I'm not using file system anymore. Using the timetable concept again. Do one more question while this is running again. There was someone else in the back had another question.
I am using an RDBMS server. When I get the data from the RDBMS and make some ETL operations, I want to save it into file storage, but I don't have a puzzle. Where can I save the data for later use?
Right, so I assume you're using Spark to read the data from.
Yes.
So you can save the data using. So if you're using, what language are you using?
Python.
Okay. So in Python, there's a function called SQL context.write. Look up the API. So you do your ETL on your table and you get a new table and just want to save it. So sorry, not SQL context, but data frame dot write, and then you pass it a bunch of options. Those options determine what's the format of the data going to be, like what are the parameters of that format. For example, if you CSV, you want header, you do not need a header, or if you want to use parquet or half-row. And then you, at the end, you call save, and you give it a path. And your path is going to be HDFS : something, right? And then that will basically save your data on HDFS, save your data frame on HDFS with the format that you asked.
But the data will be saved on a single file, but I want my data is distributed over.
No, well, if your data, the data will not be in a single file. If the data ends up in a single file, that's because you've had a single partition. So if you want more than one file, what you should do at the beginning when you read your data, repartition it and pass it the number of partitions you want, and that way all your ETL will also be much faster. One important thing to keep in mind, to take advantage of Spark parallelism, you've got to make sure your data is partitioned across nodes.
Another question, what's the advantage of using Python instead of Java heap? There is another project, you say Python, out of Java heap memory. What's the primary advantage of using that memory management?
Right. So there are two issues with heap, the on-heap memory. The first issue is that if you have two Spark applications running, they can't share RDBs. That's one issue. The second issue is that the Java heap, on-heap, keeping a lot of objects on heap causes memory pressure in JVM. So the garbage collector will wake up, and the garbage collector, the GC basically, is a very disruptive agent. When it wakes up, it basically pauses your application somewhat and starts collecting and garbage collecting memory. So that affects performance. So with Tachyon, you can address both of these problems. You store your RDBs off heap in a separate service, and then another Spark application can read that RDB from that service as well. And since you're not on heap, you don't have garbage collection issues. The second problem, which is garbage collection, is also going to be addressed, is being addressed by the Project Tungsten. Project Tungsten is basically an effort within Spark to stop using Java objects and instead use unmanaged memory. And this way, garbage collection doesn't get involved, and you won't have the performance problems with garbage collection. Any other questions? I think we are also almost out of time. Let's see. It didn't read my command. It didn't even save my command, so I was completely disconnected.
Maybe the main problem is network.
That would be so correct. Table. Or maybe my notebook is completely, wow, this notebook is completely busted. So let's retouch it. Oh, that's good there. That's good. It means I just mistyped the name of the table. Table name. Wow. Really good. Going back to scroll. I wish I had refreshed before. Again, select it. All right. It's working. I can take other questions while this is running. Yes.
So, is it can ever be possible to have multiple Spark contexts in one program?
Yes. Yes. You can have multiple Spark contexts. You can create as many Spark contexts as you want in your Spark in your cluster. Each one of them is going to be a separate application.
Yes, but they will not share RGBs.
No, they can't share tables with each other. Actually, if you want to be able to share tables and data frames, you've got to be very careful not to create more than one SQL context. So even if you have one Spark context, you've got to be careful not to create multiple SQL Spark contexts. Two concepts.
So I had a problem. It's not about Spark at all. I had the Spark context, so I was using graphics, so I had a graph chart, I had a rich graph. Then after processing some stuff, I split my graph into smaller graphs. So I wanted to have a MapReduce chart on each of them, paralleling, using parallel. But since I had one Spark context, even though my job was really small, I had to apply this in order. But maybe I would use, if I had many Spark contexts, using less memory and less cores, maybe I would run this parallel. So I don't know.
Interesting. I think if I had that issue, what I would try, if you're running the same function on this different components of your graph.
Yeah, I have many graphs, many
Right.
HRDs, for example.
So do they look different? Like they have different schema? The RDDs are different? Or the same RDD schema, just different content?
Yeah.
Same RDD schema.
Yeah.
So what I would do, I would keep them in a single RDD, but add another column, quote unquote, that identifies the component or the subgraph number. And then instead of calling the function on each subcomponent separately, I call my function on the entire data of RDD at once, and keep track of the component number. Right? This way, in one step, you get all your results. Am I clear?
But each time I need to create a graph again using this.
Also, the graphs are pretty serious. So, right. So I think there must be a way to do that. But if you post that question on the user list and CC me, I'll try to help. Let's try this. And this time, library. Should get the graph. Finally. Okay. So, as you can see, some of these bots are very active on specific topics, but others are all over the place. Sorry for the long wait to get this. Okay, I think we are out of time. I hope I have been able to answer your questions. If you have more questions, feel free to email us. The user list is a very good source of answers for posting your questions. Thank you, and I'm glad I was here. And I give it back to you guys.